relating the roots and the coefficients of quadratic equations. Everybody here know what roots of an equation is. You know what the coefficients are, right? The coefficients are a, b, and then a c, x squared, and then x follows like that. So we are trying to relate the roots of two quadratic equations. So let's say the roots are alpha and then beta. I'm not able to keep my consistency in writing the Greek and the Greek letters. Sometimes you may see me writing A and B. So you may see me writing A and B. So I just know that I'm writing alpha and beta. Okay, so if the roots are alpha and beta, you notice that I'll try my best. If I factorize it out, sometimes you could have something like alpha minus beta, and then x minus alpha, and then x minus beta. So if I have x minus alpha, x minus beta is equal to 0. If I expand this, I'll have what? X squared minus. If I expand this, what equation would I have? That would be what? Minus x beta, x alpha plus alpha beta equals 0, right? Now, simplifying this, I would have x squared minus x into bracket alpha alpha plus beta, exactly, plus alpha beta. Is that okay? Now, if I want to compare this to the standard form of equation, which is ax squared plus bx, let me put it, ax squared plus bx plus c equals 0. Okay, I think the wind. So ax squared plus bx plus c equals 0. I can say that if I want to make it monic, that would be monic. That means I want this guy to be just one term. So I divide through by a. Do you get what I just did? Okay. So I can say that my sum of roots, which is the two roots over here, sum of roots compared to this place will be what? Will be, yeah, but there's a negative sign here. So sum of roots will be equal to negative b over a. And then the product of the root is a times b will be the same as what? So product of roots c over a. Is that okay? We are doing this to come to a conclusion that, for example, if I give you two roots and ask you to get an equation for me, what do? We are used to being given the equation and have to find the root. But there are times that you are given the roots and you are asked to find the equation. Do you get that? So let's take our favorite, the equation we use a lot of times. Everybody here knows x squared plus 5x plus 6. What are the roots? What two numbers do I multiply? I multiply to get what? 6. I add to get 5. 45. What are those two values? 2, 3, 2, 3. So I would have something like x squared plus 2x plus 3x plus 6 equals 0. So it will be x into brackets x plus 2 plus 3 into brackets x plus 2. So I have x plus 3, x plus 2. So from here, x is equal to minus 2 or x is equal to minus. So now, if I am given minus 2 and minus 3, assuming I don't know this equation, and I'm asked to generate the equation as well, what do I do? Knowing this, I'll just go to this formula. So x squared minus x alpha plus alpha beta. That will be x squared minus x. What's the sum of these two roots? Minus 2 plus minus 3. Minus 5 plus minus 2 times minus 3. Positive 6. So finally I'll have x squared plus 5x plus 6 equals 0. Do you get that? So the reason for going through all of this is to help us to find equations when we are given the roots. Is that okay? All right. So having known that, let's try an example. Find the this is way simpler. Find a quadratic equation whose roots are okay, let me keep this way. Has sum of roots to be 7 and product of root to be 10. I think it should be done faster. Sum of roots is 7 and product of roots is 10. What will be our answer? Sum of roots plus 10. Do you also agree to that? Okay. So those are some. There's another way of explaining the same idea of relating the roots and the coefficients of the roots. I can use the quadratic formula to explain that. I have minus b plus or minus root of b squared minus 4ac all over 2a. What are the individual roots here? Shelly. What are the two? You know there are two roots, two things over here. X is equal to this two. This. There are two values here. What are they? It's just right there. You don't have to think so much. Of course, minus b plus the first one is minus b. So x, the first x with minus b plus root of b squared minus 4ac all over 2a. And the other one is what? It, Good. So let's see what happens. I'm looking for the sum of the root. So if these two guys are going to be the root, what will be their sum? It will be minus b plus root of b squared minus 4ac all over 2a plus minus b minus root of b squared minus 4ac all over 2a. Now, what kind of fractions are this? Of course, like fractions. So I would have my denominator to be 2a, right? Then I add those two normally. It will be minus b plus root of b squared minus 4ac minus b minus root of b squared minus 4ac. Is that okay? Some things can cancel. What are those? Perfect. So this can cancel this. And what does it leave us with? It leaves us with what? Good. Minus 2b over 2a. So if I cancel out, I would have what? So I can say that therefore the sum of roots is equal to what? Do you get that? So that's how I can relate it. Now, what if I'm looking for the product of the roots? That would mean that I would multiply these two things. Is that okay? Right. So minus b plus root of b squared minus 4ac all over times negative b all over. Now, what can you see? I had it somewhere. Difference of two squares. Perfect. So that would mean that the top guys multiplying this and this, it becomes what? Minus b all squared. You almost got it. No. Difference of two squares. Minus root of all over 4a squared. Good. So this becomes what? Positive b squared minus this whole thing would have dissolved it, right? What do I have left here? Minus b squared 4ac over 4a squared. Can you see it now? It's already showing. This and this would have gone. I have 4ac over 4a squared. So this 4a would have cancelled such that I'll now have c over a. I think this approach is a lot more, yeah, they're all cool. So the product of root is equal to c over a. So these things are not just some random concept somewhere some mathematicians want to just use to give you pain. They are things that are like relatable, we can explain it. So sum of roots is minus b over a, product of roots is c over a. Is that okay? Now, having known that, so solve this question. Find the sum and the product of roots of 2x squared plus 9x plus 10. So what we are saving you from now is to save you from having to find the root before adding them. You can now have a shortcut to do it. What's your answer? Find the sum and product of roots of 2x squared plus 9x plus 10 equals, what do you say your answers are for the sum of roots? Minus 9 over 2, product of roots 5. Is that okay? See, this is simpler. But let's confirm using any of the methods we know. Let's use factorization to see what we'll get. So 2x squared plus 9x plus 10. What two values do you multiply to get 20? Add them to get 9. 4, 5. So 4x plus 5x plus 10 equals 0. Right? So that would be 2x x plus 2, 5x plus 2 equals 0. So 2x plus 5 and then x plus 2, right? So the roots are going to be minus 5 over 2 and then or minus 2. So let's add the roots and see if we get this guy. Then we are really sure. So minus 5 over 2 plus minus 2. And then minus 5 over 2 times minus 2. This one will be minus 4 on what? 2. Do you get what I just did? Okay. So this will be minus 9 on 2. Just as it is over here. But instead of going through this stress to find it, we can have other ways to arrive at the same position without having to go through this. Do you get it? So don't be learning these things like some random isolated fact. Because I know students can learn this and they are seeing this thing as some different topic, like somewhere, like a whole ball game altogether. But I should know the relation between each and every one of them. Do you get that? Okay. And then this one obviously becomes what? Positive 5. I hope that's okay. All right. So let's look at some other things